quantized energy. So we have our different tiers of energy, right? And we say it's based off of the frequency of the wave, right? But as I've said, you don't need the wavelength. I feel like the wavelength, the best thing it's for, it's a good representation. It's a good visual representation to help people understand the differences here, right? But it's not true. It's not real, right? And you don't need frequency to explain this. The quantized energy comes from the fact that in order to move faster, like the more energy you put into something, the faster it moves, right? And in order to get something to move faster when it's really close to the speed of causality, gets substantially higher and higher. Because as we know, with relativity, if something is traveling at 99% the speed of light, when you add 0.1% to that, it does not make 100%. Right? It makes it like 0.9999 or whatever. I don't know the math, but it doesn't make it 100%. It only adds a tiny little bit onto it, right? So you got to put a lot of energy in to get it there. And eventually, that's why we say you need basically infinite energy to go the speed of causality, because the speed of causality, is everything. It's like a controlling law of what keeps our universe functioning the way it does. So if you can go faster than the speed of causality, then you're outside of time, which means you're outside of really our reality. And so that's why you can't do that, because, or at least the energy to do that is not available to us, right? So there's no going faster than it. So as you approach that, you need to put in more energy, more energy, more energy. Well, that's where the quantized energy comes from. Because in order to get a visually different wavelength of light, a different quantized energy, packet of energy, in order for them to be noticeably different, you have to pack a lot more energy into it than you would for another one, right? So for a red photon, right, a red light photon, you're putting in, I don't know, I'm just going to use numbers here. We'll say it's 0.9% the speed of light, the speed of causality, right? 0.9 the speed of causality. Okay, well, I want to send out a violet photon, right? Well, in order for me to do that, I've got to make it it has to travel at the speed 0.97. I don't know, right? And so in order for me to get it from 0.9 to 0.97, I got to put a lot more energy into it. And so there is a noticeable difference in speed and energy between these two photons it looks like they're traveling about the same speed, right? There's not an extremely noticeable difference between something traveling at 0.9 and 0.97, right? Not to us. Either way, it's really fast, right? But it is traveling, but the energy to make that difference is substantial. It is extremely substantial. And so that's why energy is quantized. Because the more energy you put in order to get it to go faster, in order for it to be a higher energy, it has to have a lot more energy put in. And that's really all I wanted to say, like to make those leaps, that 0.1 that you're adding, 0.01 that you're adding on each time you jump up in, a wavelength of light, you are adding a significantly greater amount of energy to make that jump, right? And so it seems like there's these energy tiers, boom, 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 right? And the higher the energy, the faster it's going. But that difference is not necessarily a crazy big difference in speed, but in energy, it is. And I think that's all I needed to say with this one. So, yeah. Peace out.